Class you have studied we have discussed regarding the introduction of the solidifications. So what are the things are been happening in the solidification, what are the required of the solidifications, and after solidification, when the solidification is process carried out in the molding box or in the casting, when the liquid metal starts to convert into solid metals. So the how the crystals are generated, what is the nuclei, how the nuclei are created, okay, and the types of the nuclei we have studied in the previous class. The heterogeneous nucleus, how they are generated, and the homogeneous nucleus, how they are generated, that also we have discussed in the previous class. Now today we will start with the solidification variables. Okay, so some of the variables has to be consideration during the solidification of the molten metal. Okay, so these are the important variables which has to be understand and has to be controlled for the better solidifications. Okay, the solidification process by which the liquid metal freezed in a mold play, that is an can say the mold cavity, okay, in a crucial roles because the different solidification condition gives rise in the different microstructure. Okay, so the whatever the solidification conditions are there, okay, the microstructure of that particular casting is depend on that one. Now next, and hence the properties of the casting alloys. Okay, the casting alloys also plays a very important roles in the solidifications. The variables affecting the solidification behaviors of an casting includes, so these are the following. So what is that, we will see. The first one is the type or the compositions of the casting alloys. So see, the alloy consists of an base metal to which the other elements are added to obtain the favorable property properties. So what does it means? The main components of which you are going to prepare the casting, okay, either it may be the copper, aluminium, ms material, mild steel, or the cast iron, or the gunmetal. For that base material or the maximum percentage of the common material which you are going to melt, for that material some of the alloys or the other material metals are being added, okay, to get the desirable properties. Desirable properties means what? Different types of properties, whatever you require when that finished product is come out by the casting, some of the other components or the metals are being added in that one, so that you will get some of the desired properties over there. Okay, for that reason the alloys are being used to adopt the properties. Now this alloys also plays a very important role during the solidification. See, the base metals which is having the solidification timing, okay, just imagine, I have an example. If you are having an gun metal which is having the solidification timing, it requires one half an hour or 1 hour to solidified completely. If you add any other material, if for example copper of any other material, it will takes near about half an hour. So the base metal take 1 hour and the alloy taken half an hour. Okay, so the alloy will first solidified, then the base metal start to solidified. So this type of solidification methods, okay, has to be controlled by adding the percentage of the alloys in a proper way. Okay, this proper control of alloying elements promotes, hello, what happened? Hello, okay, any doubt? So this thus the proper control of these types of alloys the promote the constitutional supercooling, and further the additional use of an insulator agent to promote the heterogeneous nucleation. So over here the heterogeneous nucleation is what means what, in the previous class we have studied. So see, this alloy firstly solidified, then the base metal starts to solidified. Okay, so which alloy is first solidified, that makes the other molecular components of the base metals to starts to solidify. So this is called as an heterogeneous solidification, or the generation of the nucleation, or the generation of the new molecules in the base metal, okay, is done by the this heterogeneous phenomena. Okay, nucleation resulting in a fine grains structure in the method. So this is how the types of composition and the casting alloys has to be kept in considerations as the solidification variables. Okay, now next is the thermal property of both the alloys and the molding materials and the cooling rate. Okay, thermal property means what? Heat absorptions and heat extractions. Okay, at how much maximum temperature it can absorb the heat of the melting point, what is the melting point, what is the freezing point. So these are the thermal properties of a particular material or the iron or the alloy which you are going to use. And the molding material means what? The green sand or the sand which you are using for making an mold, as well as the molding box. And next one is an cooling rate is the freezing rate from where it starts to solidify. The heat released during a solidification is an very large. Okay, so whatever the heat is being released, obviously when the heat starts to release, then only the solidification will start. As much it exhibits quickly, how much faster the heat will release, at faster rate the solidification will apply. The higher the melting points and the thermal conductivity of the material used in a casting. Okay, higher the melting point and the thermal conductive material used in the casting. So as it should melt at a higher rate. Okay, and solidified also on high rate. The melting should be slow and the solidification also should be slow, so the 100% solidification can be achieved. The larger in the lateral heat and the heat release and the absorbs. Okay, so over here the heat should be released and absorbed during the fusion system. So this is how the thermal property should require. It is an important to note that the grain size affected to the strength and the hardness of the casting. Okay, the metallic mold produce a higher cooling rate than the sand mold under the some operating conditions. So see over here, if the solidification is done in a faster rate, if the high heat is released as fast, so what will happen? The grain size will also increase in a faster rates. Okay, if the grains are in faster rates, so the mechanical property of that particular material which has been solidified will also change. If the grains are being slowly developed or slowly increase or adopt its position in the liquid metal or in the solid metals, that means what? The solidification is in slow process, the temperature gradient is in a slow process. So the even it is in a slow, it also adopts its own temperature. Okay, if it is slow, the material may be the ductile or an softer one property it will obtain. Okay, if it is an hard, if it is in solidified in a faster rate means what? Sudden cooling is happen and sudden solidification is happening, so it will become an hard one. Okay, that is an hardened property it will require. So while during the solidification you should have the careful during the thermal properties of that particular material which is going to be cast. Okay, so this is one of the important variable to be considered, so that you can uh, adopt or you can have the required property of that cast material. Okay, the mold thickness and the shape. So see, the mold thickness and the shape also plays a very important role in the solidification. If the thickness of the mold is a thinner one, what will happen? The percentage of the heat will release out in a maximum rate. Okay, if it is an high thickness or the larger thickness, so the heat doesn't pass away to the mold box or the mold wall or the molded sand. Okay, in a faster rate. Okay, that what will happen? If it is heat is releasing from the mold box in a faster rate, the solidification also taken in a faster rate, will done in a fast rate. If the heat is not releasing, if the heat is not releasing in a faster rate, so what will happen? The solidification doesn't doesn't go in a faster rate, it will take a slow time to solidified over there. Okay, if it's taking the slow time for the solidification, obviously the required desired property it can be adopt over there. So this is one of the important variable that has to be keep in your mind. Now next fourth variables what they have given, chills, getting and other casting design factors. Okay, what do you mean by the chill? So see, the chills are nothing but the two different types of chillings are done during the solidification in the mold box. One is an internal and another one is an external chilling. So in the internal chilling what they do, so whatever the liquid metal, okay, the liquid metal which is poured in the mold cavity, of that liquid metal same composition or the same base metal, one hard solid uh, piece, okay, of that metal is been dipped into the molten metal, in that molten metal, so that heterogeneous nucleation occurs in a faster rate, due to which the solidification rate is been increased over here. This is how the internal chilling is been done. And in the external chilling what is happening, so see, whatever the molding box is capped in which the mold cavity is there, okay, at the side of that molding box the sprinkle of the water has been done, or any of the cooling agent is been done at the outside of the box, so that with the sprinkling of the water the heat inside the mold cavity which is releasing by the that molten metal is been coming is been extracted out, or allow that heat to come out from that molding box and make the solidification rate in a faster way. This is how the chilling is been done. Now the gating and other casting designs. So see, there are runners and risers and the gates are being used in a casting, okay, for removing of the casting in the mold cavity. When you pour the molten metal, it goes through the runner by the means of gates and enter to the mold cavity. Then afterwards completing of the mold cavity, filling of the mold cavity, it's come out by the riser. So see, the gate shape, runner, risers and the gate shapes plays a very important roles in the solidification. So see, during the solidification it is not only that the liquid should convert into a solid part, it one point is to be considered, but during the solidification you have to consider that each and every liquid which is entered in the mold cavity should get solidified. Okay, then next is the shrinkage. Shrinkage is also is play sorry, shrinkage is also playing a very important role during the solidification. Okay, so that has to be also avoided. Okay, that can be avoided by the means of runner, risers and the gates. Okay, with the gates complete mold cavity should filled, and the risers from where the mold cavity is the molten metal is coming out after filling the mold cavity, then the remaining the extra molten metal is been reserved in the riser. Okay, how the solidification process is been start in the mold cavity, in the molding box. Okay, at that moment whatever the liquid metal is which is reserved in the riser, that has been reversed back to that mold cavity and fulfill the tolerance which is been tolerance of the dimensions in the, okay, the shrinkage tolerance which is given during the making the pattern and the mold cavity, that tolerance is been fulfilled by the liquid metal which is results in the riser, okay, by reversing back it to the mold cavity. So this is one of the consideration is to be taken or the variable during the solidification. Okay, now the pouring temperature. So see, the pouring temperature plays a very important role in the solidification. So from in the furnace you are melting a metal, from that metals, okay, obviously the temperature in the furnace is very high, but when it pours into a ladle or a crucible cup, okay, the liquid molten metal, it directly comes to in contact with an atmosphere the temperature suddenly drop chances have been there. Okay, the temperature starts to suddenly drop when the molten metal during the pouring in a crucible cups comes to the contact with an atmosphere. From that pouring station or the furnace station to the molding box, the person who is taking carrying that one, it is continuously comes with the contacts with an atmosphere and released or reduced this temperature. Reducing temperature means what? The molten metal before entering in the mold cavity starts to solidified over there. So this is a very important variable, that the molten metal should not start to solidified before pouring in the mold cavity. It should maintain its temperature before pouring the molten metal into a mold cavity. So this is one of the very important pouring temperature variables you have to keep in your mind. Now let us see the directional solidification and its needs in the casting. So far you have now we have discussed regarding the variables which has to be kept into and controls, okay, during the solidification. Now we will see the directional solidification and its needs in the casting. Before going to this concept, I will tell you what is the directional solidifications and why it is required in the casting. So see, in everybody you have seen the chimney is there, okay, where the fire is been put, from where a huge pipe is been given. In the industries also you have seen, in your home also you have seen, where the water bum is there, which is a water bum is a boiler where you are heating the water, sorry, from where the smoke is coming out from that chimney, okay, that the direction is given to smoke to come out and exposed to the atmosphere. Like this way a particular direction is given for the solidification. From that direction only the liquid metal starts to cool, okay, by the step by step, and it is to be converted into an solid, okay. Now let us see how the direction of solidification work. Hence the casting must be so designed with a respect to a feeding system such that the part of the mold is that fastest from the feeder, and heat must solidified first, fastest than the feeder head must solidified first, then the proceed to a, or the casting towards the feeder head, and the solidification which is made to occur in the particular direction. So see, the solidification which is made to occur in a particular direction is called as an directional solidification. Okay, now I will tell you with the pen, I will draw the sketch. So see, this is a molding box in which this is the casting, and from over here this is a gate. Okay, when you pour the liquid molten metal over here, it enters the mold cavity and it comes out of the riser. Okay, at that moment what is happening, when the mold cavity is entering over here, okay, in the directional solidification how it is designed, from where the molten metal is been feed, okay, this is a runner, where the molten metal is been feed, from this side only it starts to solidify. This is what the direction is to be applied for the solidification, okay. From over here it starts to solidified, okay, then the mold cavity is to be solidified, and at the last this riser is to be solidified. So this is what the direction given for the solidification done. This type of solidification method is called as an directional solidification, okay. Directional solidification can be described as a solidification of the molten metal taking place in such a manner that the liquid feeder metal is always available for the portion of a metal for the solidification. So see, just I will say, let us see if there is a whiteboard to share you. Okay. So see, this is a molding box. Okay, in this molding box here is a mold cavity. Okay, in this mold cavity this is an runner, and over here is an riser. Okay, from this you are pouring a liquid metal, okay, by the runner. By this gate it enters the mold cavity. Then afterwards, filling this mold cavity, the excess molten metal is been coming out from this riser. Okay, so this is an runner, and this one is an riser. Okay, and this is an cavity. Now how the directional solidification is being carried out? Okay, so what is the intention of the direction solidification should be done? So see, whatever the molten metal you are pouring through the runner, it should solidify from this direction, the direction. Okay, from this direction it start to solidify, then it comes to over here. So see, this riser should solidified at the last. Why? Because the casting should be designed in such a manner that the runner starts to solidify first, then the mold cavity, and then the last this riser should be solidified. Okay, why? Because there are the some reasons are there. In the previous class also I have discussed, or in the class also I have told regarding the concepts of the gates and the riser. Once again I will tell you. From over here the molten metal is entering. Okay, it enters the mold cavity and it's come over here. When see, see over here there is a molten metal. In this cavity there is a molten metal. This is a runner. Over here molten metal. Okay, when this runner starts to solidify, this cavity starts to solidify. Then afterwards what happens? Okay, the cavity which is in this mold cavity, it should be in square. It starts to shrink. Shrink means what? The volume starts to reduce over there. The dimension starts to reduce of that casting as it starts to solidified. At that moment what happens? This riser in which there is an liquid metal which solidified after the cavity solidification. Once this cavity has been solidified, after this riser starts to solidify. But okay, it's also plays the work like a reservoir. Reservoir means what? You have seen the dam, okay, lakes where the water is being collected as per the requirement. The water is being supplied to the homes or any of the fields, okay, for drinking purpose. Like this way, this also works like an reservoir, okay, riser. Whichever the liquid molten metal is collected over here, as soon as the solidification starts in the mold cavity, the molten metal starts to compress or shrink or reduce its volume. Okay, the size starts to reduce as its solidification starts. At that moment the sum of the liquid material is been supplied back to the mold cavity, so that the maximum shrinkage will occurs, maximum dimension of the cavity, or sorry, the molten metal can compress or shrink. Okay, to avoid the shrinkage defects or to overcome the shrinkage tolerance, this riser is been work like a reservoir. Okay, so like this way the directional solidification is done, because okay, this riser should not solidified first, okay, before the cavity. The solidification should start to the runner, so that this riser can supply the liquid material to the mold cavity for avoiding the shrinkage defect. So, the directional solidification is done from the runner to cavity, then the cavity to the riser. Once the cavity is been solidified, then the riser should solidified. So, this is how the direction given for the solidification process. Okay. So, this process is called as an directional solidification method. Okay. This is how the directional solidification is been done. I hope you have understood this one. Now once again we will go for the okay. Now next we will see the progressive solidification. The directional solidification can be described as the solidification of the molten metal taking place in such a manner that the liquid feed metal is always available for the portion of the metal that is just solidified. Okay. So, see the directional solidification what they are telling can be described the solidification of the molten metal taking place in such a manner that the liquid feed metal is always available for the portion of the metal just solidified. It can be described as the solidification of the molten metal taking place progressively from the thinnest part, okay, where there is a thin part is there, from there the solidification should start towards the feeder head, that is a riser. Okay, the riser is there, just now I've told where the solidification at that the riser should be solidified at the last, okay, which is the solidifying last. Okay. Now the directional solidification and the progressive solidification. The progressive solidification is also one of the another method. Parallel solidifications, okay, are the two types of solidification in the casting, hints not to confuse with each other. Okay, please don't confuse with each other. So these are the two different types of solidification casting different, but they works parallelly. Although this process shares some common traits, okay, they are having some common traits. The difference lines in that okay, in that in a progressive we'll see the cooling and the solidification process in the progressive at the wall of the casting and work in a way inwards with the directional solidification. So from the wall of the mold cavity where the molding box are there, okay, from the sides of that molding box the cooling is starts to be done, or the solidifying process is starts to be done. Okay, this is what called as an progressive solidifications. Okay, so there are some methods and the factors are to be controlled during the directional solidification. Now let us discuss that one. Okay, first one is in proper design and the proportioning of the gates and the riser. Just now I have told you that how the riser should be there and how the runner should be there. What is the intention behind that one? Okay, that you are going to study. okay, because before the shape and the runner risers and the gate should be consideration, so that you if the required shape is been taken, then only you can achieve the directional solidification. Okay, the use of an insulating pads and the sleeves for the risers. Okay, you have to use the insulating pads and the sleeves for the risers. Use of an chills in the mold, I have explained what is an chills. Okay, incooperative binders and use an exothermic risers. So see, these are the some of the important methods and the factors which has to be taken in a consideration during the directional solidification. Now let us see which that one by some of the details in regarding that one. So the proper designing and the positioning of an gates and risers. So see, the gates and risers should be in a proper position. Okay, so from the runner where the molten metal is enters, it should pass through the gates and easily enters to the mold cavity. After filling that mold cavity, it should pass to the riser. Okay, so the movements and the flow of the runner molten metal should be in a proper manner or within the solidification timing. Okay, that has to be considered properly. Okay, so the gate should not be bigger one, it should be a shorter one. It should be near to the mold cavity. Runners and risers should be in a taper shape. Okay, the cylindrical or the spherical shape is very good for the runner and riser in spite of the square shape, because in the square there is a losses of an speed, okay, of the molten metal. The molten metal doesn't get an accurate speed of an flow to enter the mold cavity. For that reason the cylindrical or the spherical shape is been used. Okay, now next, use of an insulating pads or the sleeves or the riser. So see, the insulating pads are being used. Okay, the sides of the risers are insulated with a sleeves made from a suitable material so as to achieve the lower solidification rate in the risers. So see, the riser should be insulated properly. Okay, because just now I have told that riser works like a reservoir. The molten metal which is stored in the riser should be solidified last after the runner and the mold cavity material solidification. Okay, because the riser supplies the liquid molten metal to the the solidified solidifying material in the cavity. Okay, so it continuously supplying the liquid metals so that it can avoid the shrinkage defects and overcome the tolerance of the shrinkage. For that reason the riser should be insulated properly so that it should not solidified first before the runner and the cavity metal. Okay, for that reason the insulation is been done for the riser. So what are the insulations are done and how it is done? So see, the riser which is exposed to the atmosphere, which is coming out of the mouth of that riser, is coming of that mold cavity. Okay, at that face or the top the pad is been kept or any core is been kept so that the temperature or the heat from the top of the molding box by through the riser should not come out and exposed to the atmosphere. Okay, it has been stopped over there by covering the riser. This one, the sleeves may be made of the plaster of Paris or a non-ferrous materials. Okay, that sleeves or the clay, fire clay wash dust. Okay, that has been placed over there. Cellulose material like rice slabs are also used. Insulating pad is been kept on the top of the riser. Okay, so this is how the temperature of the riser is been maintained to avoid the faster rate of an solidifications. Okay, now next we will go for the use of an chills in the mold. So I have explained regarding this one previously. Internal chill and external chill. Internal chill is nothing but the base material which you are going to make the casting of. That solid part or the solid part metal is been inserted in that liquid one. Okay, so that solid part will comes with the contact with the molten metal and starts to generate the heterogeneous nuclei inside the molten metal, by which the solidification rate increase in the faster way. Okay, so this is what the internal chilling is been done. Then the external chilling is nothing but the spray of the water or putting any of the solid particles, cooled particles in within the molding box or the mold walls. Okay, so that it can extract the heat from the liquid molten metal and release it out, by which the uh, what you can say, the faster rate of the solidification is been can be done. Okay, this is how the chill in the external and the internal has been worked out. Okay, so this is how the factors and the methods of controlling the directional solidification. Now next we will go for the use of an blind riser. So see, in the molding box you are just so far of a diagram. Okay, different types of risers, yeah, you have studied in the class. Okay, blind riser is a blind riser means what? The runner from where the molten metal is coming, it enters to the mold cavity and go for the riser. In the riser, when the molten metal is filled in the riser, that doesn't come out of the molding box, because the riser is made inside the molding box below the surface of the mold. Okay, the riser is not exposed to the atmosphere. Whatever the molten metal is not coming out of the box, it is within the mold cavity. Okay, so these types of risers are called blind riser. These types of blind risers are being used for the directional solidification, so that the risers can be that riser liquid can be solidification rate can be reduced over there. If the solidification rate of the riser is been reduced, finish.